Hello, 8th grade math students. Mr. Lawrence here, and it should be Wednesday, April 29th. If you're watching this on time, we're going to learn how to sketch some graphs. These graphs are going to explain situations that are happening. Kind of like I did in the last video where I kept interpreting the graph. Well, now we're going to make a graph that somebody can interpret. So let's go back to our old friend Jay, and wait, I can't find the play button. Jay, what did you do with the play button? Here we go.
When you draw a graph without actual data, you are making a sketch. A sketch can help you to visualize relationships. Consider the following situation. An athlete measures her pulse rate during a 50-minute workout. The workout includes a 10-minute warm-up period and a 5-minute cool-down period. Sketch and label a graph showing her pulse rate during her workout. Step 1. Identify the two variables being related. The variables being related are time, t, and pulse rate, r. Use the variables to label your graph, showing time on the horizontal axis. The workout lasts for 50 minutes.
I can't ever think of a situation where time is not on the horizontal axis. It's your independent variable, it's x. The other variable, pulse rate in this case, depends on how long you're exercising for, not the other way around. So time is always your independent variable and goes along the x-axis, well in this case the t-axis.
Minutes. Step 2. Look for key words that describe the relationship. Warm-up means that her pulse rate is increasing. Cool down means that her pulse rate is slowing down or decreasing. Step 3. Sketch and label the graph.
Don't forget to analyze the situation before you graph it.
Okay, so here's how Mr. Lawrence would handle this. I know that there is a 10-minute warm-up period to this problem, to this situation, right? So I know that I'm going to put a vertical line here. This is not drawn. This is just for me to demonstrate. Okay, I'm going to take it out. It is not a part of my graph. That somewhere along here is going to be the warm-up period. Okay, I also know that there's a 5-minute cool-down period, and so that would be the last 5 minutes of the graph. Okay, so the end of the graph will be at 50 minutes. So the pulse rate is probably going to begin, you know, if they're in decent shape, maybe somewhere around here. Okay, and it's going to steadily increase until they get it to the level that they want it to go, and then it'll stay at a constant rate until they get to their cool down, and then it'll go back to normal. Now I made a small mistake there. I put it right here. Why would this be ridiculous? Well, that would mean the pulse rate were 0, which would mean they didn't have a pulse rate, which means their heart's not beating. So I'm going to get rid of these lines because they do not belong in the graph. They were just there to help me find my intervals. Okay, and so the pulse rate is going to be steadily increasing, and then it's going to remain constant, and then it's going to decrease back down to a level that it was at a resting heart rate, or pretty close to it. And there you go. There is the entire graph. Yeah, it's actually pretty simple stuff. Paying attention to your labels and your time intervals. So now let's see if we can do this problem. An airplane flew from Melbourne, Australia to Sydney, Australia in 85 minutes. The plane took 20 minutes to reach its cruising altitude, 15 minutes to descend to Sydney. Sketch a graph that shows the plane's altitude during flight. Well, it sounds like I heard time mentioned an awful lot, right? Minutes kept getting mentioned. So this is going to be the time. Oops, I don't want to be in highlighter mode. Sorry about that. This is going to be the time, and that'll be in minutes. Okay, and this here is going to be the altitude, or how high the plane is off the ground. Okay, and I think that's in feet, but we're not actually measuring it out. Okay, typically altitude is measured in feet. Now, I'm going to make each block 10 minutes. So this will be 20 minutes, and then 40, and then 60, which is an hour, right? And then 80, and then 100, 120. I feel like I've made a mistake. 40, 60, 80, 100, 120. No, that's okay. That's 2 hours right there. Yeah, that's okay. That'll work. Okay, so now let me mark my intervals, right? So the plane takes 20 minutes to reach its cruising altitude. Well, the plane starts on the ground, so its starting altitude is 0. And at 20 minutes, it's at whatever cruising altitude we want it to be at. Now it stays at that cruising altitude until the last 15 minutes, which it descends to Sydney. So it's going to land here. Oh, how did I know it was going to be 120 minutes? Well, I took the 85, the 20, and the 15, and I added them all up. Okay, and I got 120. So I knew it was going to be a 2-hour flight. Now, the last 15 minutes, if each block is 10 minutes, then this cruising altitude is going to go till about the halfway point there. And now I'm ready to sketch my graph. Okay, so the plane is taking the first 20 minutes to get up to its cruising altitude. Then it stays at that cruising altitude for 85 minutes. And then it descends and lands in the next city, the place, its destination. Okay? Pretty simple stuff, ladies and gentlemen. Pretty simple stuff. All right. Let me see. I think I want to jump. Yeah, I want to go back to here and bring up part 2. Having a little trouble here. There we go. Okay. And it says, these two situations describe actions that take place after school. A, you leave home and ride your bicycle to the library, where you stay for a while doing research for your science report. Then you ride to your friend's house. B, you ride your bicycle home from soccer practice. On the way, you stop at your friend's house for a while, then go straight home. Okay, so let's take a look at these graphs here. All right. So, distance from home. This one is not starting at home because the distance from home is greater than 0. This one is starting at home because the distance from home is 0. Now, this one, the person does not end up at home at the end of the story, but at this one, they do. We're supposed to match the story with the graph. Well, it's pretty simple since one of them starts from home and one doesn't. So, you leave home and ride your bicycle to the library. This must be the top one. The bottom one. Because you're leaving home, you go to the library, you stay for a while, and then you ride to your friend's house. Okay, hopefully you come back at some point, but that's what it's showing us in the story. Now this one says you ride home from soccer, so here we're riding home from soccer, but we stop at our friend's house, hang out a little bit, and then go straight home. And so this must be B. Okay? Pretty simple stuff. All right. Each graph describes the height of a candle over a certain period of time. Which graph is not reasonable description for this situation? You light a candle and let it burn until it burns out. Which is not? I don't like 2 of them, but okay, I don't like this one because this would be notice the height is not changing. Is it possible to light a candle and have it stay the same height indefinitely? I don't think so. The only way it could stay the same height is if you didn't light it. So I don't like choice 3 at all. Choice 1, I guess this one's possible because the candle's not lit, so it's staying the same height. Now the candle's lit for a while. Somebody blows it out, and then they relight it, and then the candle blows out again, and then they relight it. So I guess 1 is okay. 2 is the best choice because it just continuously burns down until there's nothing left, or just a little bit left. Okay, so if it's asking for which one is not reasonable, I would say it'd have to be 3. Let's see what they say. Yep, there we go. Okay. All right. Okay, so you might have heard me mention in the last one, what additional information do you need to know? Well, I mentioned here that the candle must be being blown out. Yeah, the candle must be being blown out at these. Here it's continuously burning. So to know if this was a candle graph, you'd have to know, was the candle lit the entire time? Okay, if it goes out for a little bit 3 times, then 1 is your answer. If the candle remains lit the entire time, then 2 is your answer. All right, that's it for the video, guys. It should not be that difficult. Please, please, please check out the Google Classroom. Come in and see me. Make a request to do a Google Meet. We'll be doing a Google Meet on Thursday. We'd love to see all of you there. All right, Mr. Lawrence signing off. Have a good day, everybody.